All right, so now we want to find the thevenin equivalent for this circuit that has dependent sources. So V open circuit still works just fine because that's just the definition. So we need to find V open circuit. It's R thevenin that's different because you can't short out or make open the dependent sources. So let's take a look that if we look at this circuit, we have that the current so we have I going through this loop. So I have I coming down here. I have 20I going here. Now notice if I have I coming through this branch, I also have I going through this branch. So I've got I all throughout this left-hand loop. That means that Ix has to equal 0. Ix has to equal 0. Okay, so then we can say that V thevenin, which equals V open circuit, equals VAB. So that would be the voltage across this 25 ohm resistor. So if we look at that 25 ohm resistor, we've got a current of 20I going that direction. So if I want VAB, the current going from A to B is negative 20I. Because 20I is going up, so negative 20I is going down. And so VAB will be negative 20I, that's the current, times the resistance, which is 25. So that would be negative 500I is VAB. Okay, so I know what it is in terms of I, now I need to find I. So let's take a look at the left-hand loop here. If I make this ground at the bottom, then I have 5 volts here. And what is V the voltage of? V is the voltage across the 25 ohm resistor. So V is this voltage that we just found right here. So V is negative 500I. And so the voltage up here is negative 1500I. And so I equals 5 minus negative 1500 over 1500I over 2000, or 2000I equals 5 plus 1500I, or 500I equals 5, or I equals 5 over 500, or 0.01 amps. I subtracted wrong. No, I didn't. Let's see. What did I do wrong? Is it what?
It's not 100 milliamps.
I get that it's 10 milliamps, but it's not supposed to be. Oh, yeah, it is. Yeah, it is. That's right. Yeah. So how'd you get 100?
Oh, I don't know. I think it's 500.
No, it's right. I have it right. So then V thevenin is negative 500 times 0.01, which is negative 5 volts. Now for this one, we can't do resistor simplification, which makes us sad because that would be a lot easier. So instead, we're going to use the short circuit, open circuit method. And we want to find the current through the short circuit. And then we can say that R thevenin equals V open circuit over I short circuit.
Can I ask you a couple questions?
Sure. Yep.
Can you go back up to your work real quick?
Yep.
So for I equals 5 minus 1500 I,
Yep.
the 5 is in front of the minus because of the way the current's going right there?
That's right. So when you do the current, you always do the voltage. So the direction of the current, you do the voltage where you start minus the voltage where you end over the resistance in between. So VA minus VB over the resistance in between.
And then can you explain how we got the I for the whole loop on the left side?
Right here?
Yeah, like how, so
Yeah.
I see how, like, it's given at the top, now the 2 kilo ohm resistor.
Mm-hmm.
And then at the bottom left, you drew how I is right there.
Mm-hmm.
Just kind of like confused on how you.
Okay, sure. Okay. So things that are in series have to have the same current. And so when I look at the left-hand loop, I see, and things are in series where if I'm the current and I'm traveling along, I don't have any choice but to go through them. I don't have a place where I can branch off. And so when I start right here and I travel around, I go through the voltage source, I go through the 2 kilo ohm resistor, I go through this dependent source, I go through all 3 of them. I don't have any choice but to go anywhere else. That means these 3 are all in series, and so they all have to have the same current. I know the current through the top branch is I, so that means the current through both of these branches is also I. So I have I coming down here. Well, if I is coming down here, finally here I have a chance where I could go this way or I could go this way, except I can't because I already know that the current in this branch is I because it has to be I going through the voltage source. And so by Kirchhoff's laws, if I have I coming in here and I going off to the left, then going off to the right has to be 0.
So you know it's I going, it has to be I going through the voltage source because it's in series with the resistor?
That's right. Everything that's in series has to have the same current. Yep. So that's how I knew that. And then you had another question too, right?
Oh, yeah.
Okay, and that was it? Okay. All right. Okay. Any other questions? All right. So now let's see if we can find that short circuit current. So what we're going to do is we're going to short this out, and I need the current going from where I've labeled the positive to where I've labeled the negative. That's the direction that I need to have it, if that's how I've done my thevenin. And let's see, everything remained the same about the left-hand loop. That still is all going to be I, and Ix is still going to be 0. Adding the short circuit hasn't changed that. And so we now know that we would have this loop except for the fact that it's a dependent source, which makes it dependent. It's not going to depend on any Ix coming in here because that's 0. Okay, so do we have any current, are we going to have any current at all going through the 25 ohm resistor?
No.
No current going through the 25 ohm resistor because we've shorted it out. When you have two things in parallel, if I had like a 1 ohm resistor and a 50 million ohm resistor, then almost all the current is going to go through the 1 ohm resistor because current division will say most of it will go through the least resistance, and if you have no resistance, all of the current will go through it. So when you have a short, a short in parallel with the resistor, no current is going to go through the resistor. So we know that I short circuit has to equal minus 20I because 20I is going this direction. None of it is going to the left. We already know that. It's all going to the right, and it's going up. I short circuit is labeled going down. So it's going to be the negative of 20I. Okay. So now so we can't use the values that we had before because this is a new circuit, and so VAB is not what it was before because we now have a current flowing through it. What is VAB right now in this circuit with the short? What's the voltage change across just a wire? 0. So if you don't have any kind of element in here, then the voltage difference is going to be 0. So VAB is 0. That means that V is also 0, which means that this this voltage source is 0 because it depends on V. So now if we look at our left-hand loop, this was 3V, but 3V is now 0. So there's no voltage change across here. So now we just have a loop that just has a voltage source and a resistor. So we can just say V equals IR, or 5 equals I times 2000, or I equals 5 over 2000, or I equals 2.5 milliamps, which I'd like to pretend I did in my head. I almost did, but I remember seeing it on the solutions and then I verified it in my head. So that means I short circuit, which is negative 20I, is negative 20 times 0.0025. I'm at the end of my... Let's see. Which is negative 0.05. Negative 0.05. So I short circuit is negative 0.05 amps. Okay, so now we know that, make sure I wrote it right up there, I did. Okay, so R thevenin equals V thevenin over I short circuit. Now V thevenin for this one was, did I find V? What was it? Negative 5? I feel like I did that, but I don't remember where. Was it way up here? Yeah, there it is, yeah. So V thevenin was negative 5. And I short circuit is negative 0.05. And so R thevenin is 100 ohms. And we get a positive number, which is good because resistances have to be positive. So our thevenin equivalent circuit is a voltage source that's 5 volts. And notice I just put the negative on top rather than calling it a negative voltage, but I could have done it either way. And a 100 ohm resistor. So as far as the load on AB is concerned, all of this mess over here, as far as it's concerned, acts just like a 5 volt voltage source and a 100 ohm resistor. So any questions on that?
This probably be like probably one of the harder ones on.
Yes.
Yeah.
As a matter of fact, I doubt you'd have one this hard on the test. I'm going to stop the recording
And you put the polarities like that because
because it would